JUnit is a habit, not an afterthought. Appendix C, JUnit complete assertions and assumptions API for the brave. Now let's go on. What I will do, I will essentially name the one instance of a particular method, which is usually overloaded many times, and then I will scroll through the slide rather quickly. What I would urge you to do is, after watching this appendix, I would urge you to go to the course PDFs and to seek out this appendix's PDF file and to review it thoroughly. So let us go to the next slide. This is the API from the org.junit.jupyter.api package, in particular from the from the assertions and assumptions classes. It's late. Your best bet is to learn it really well is to get a pen and paper and to write each method down. I'm not kidding. Well, if you want to get it pad down, or you can just write a type of a method. You'll see later what I mean. Please note some API methods use the functional supplier type T interface or its derivatives, such as Boolean supplier or throw-in supplier type T. You can read more about this interface in the Java API Java docs at the Oracle website. You should also read up on Java's stream type T class. So let's get started and later check the source for the complete API that you should be able to recognize. And once you allocate the PDF for this appendix, you can click on the line below in blue and it will take you to the JUnit 5.6.2 API reference page. Or alternatively, it might take you to the current version's API reference page, which is still okay. So let's be brave. There is a lot of API here following. Let's go. The first is org.junit.jupyter.api module, org.junit.jupyter.api.assertions class. And it has static methods that we can import either in bulk or individually with the use of the static import semantic. So the first type of method is assert equals methods, and there are lots and lots of them, and I'll spend around maybe 30 seconds rather quick on each slide for you to familiarize with each type of method and its overloads. So let's go for this one. I'm going to give you about 30 seconds. Next, some more assert equals methods. So you should have about 30 seconds to look through them. And there are slides upon slides of just assert equals methods with the overloads and whatnot. Next, more assert equals methods, and it's literally limitless number of overloads for all cases that you might encounter in your test writing practice. Next, more assert equals methods. assert equals. All manner of primitive data types, all manner of wrapper data types, all manner of object data types, etc. Some just with 2 parameters, others with a string message that is basically displayed if assert fails, others with a supplier of type string that is displayed if the assert fails, etc. Next, some more assert equals methods. And I make light a little bit about the number of assert equals, but trust me, none of them is superfluous. They are exactly the number that it should be. It's just Java is very varied and you need a lot of overloads to kind of account for every potential necessity. Some more assert equals cases. We are continuing with assert equals. You can see we are progressing through data types, though, so we are definitely making some progress. Assert equals, now we're on to character data, then to double data. We've gone through some data types already, so we are well into assert equals methods, although I would imagine there are quite a few slides that remain. And it has so many overloads just because it's the most popular method you are going to use most of the time. Some more assert equals, we're on the double. Now we're going through float. And we've seen, I think, float and double before, but in a different arrangement of primitive versus wrapper. Some more assert equals. You can see that virtually every permutation, I mean virtually all the permutations are accounted for here, so whatever you have in mind you can carry out. The only thing is to remember that implicit conversions, widening implicit conversions, in fact, need to be followed according to your intent. If you provide an int value, for example, and invoke it in something that you want to double there, but the compiler can find an assert equals to put the actual int there, you're not going to be invoking the exact correct method, which may not be what you want. So you have to be careful with the widening conversion of data types for this. All right, some more assert equals. and some more assert equals. Excuse me. You can see here that we are actually having an object compared to an object compared to an object. Also, please keep in mind that the expected value is the first one, whereas the actual value is the second one. It's easy to mix them up and mostly harmless, but that's still a semantic error. So we should keep it as the designers intended. Some more assert equals, and I am guessing we're attaining the end of our assert equals torture, so to speak. So we're getting to the end of the assert equals to translate to the next method, assert not equals, which has nearly as many overloads. Alright, and we're done with the assert equals method. Now we're on to assert not equals method, which is going to have just about as many overloads as the assert equals method. So we're still going to do the same thing, about 30 seconds per page. So let's use the next 30 seconds to look through this slide. Next is some more assert not equals, and you can see that every permutation you will ever need is accounted for, is encountered and is accounted for eventually in this tremendous litany of overloads. Some more assert not equals, and it works according to the same pragma, if you will. You have a first value is unexpected value. Well, it is unexpected because it assert not equals the actual value, and you may have a message supplier if the assertion fails, or a string message if the assertion fails. So sometimes you will have also another parameter, for example, if you are allowed to have a difference between these two values, and anything that is within this difference passes, anything that's not fails. Alright, next page. And we're basically going through the same types of overloads as with assert equals. We're going through various primitive and wrapper data types, various object data types, etc. Now, this time I'm providing is actually a good time for you to try to scan with your eyes these overloads, just to get a basic visual grip on the number and variety and the totality of these overloads. So the next page of assert not equals methods. As well as gaining tremendous respect for the API developers of JUnit, they have been very thorough in accounting for every use case, however major or minute you might encounter. Next page of assert not equals methods. Next page of assert not equals methods, some more. We're going through the paces through various primitive data types, wrapper data types, for example, an int primitive and an integer wrapper, and also we're going to see some object overloads. Please note we don't have string overloads, so if you want to compare strings, you can use the object overloads. Alright, next page of assert not equals methods. You will notice that it's called, well, I abridged it a little bit, it's called JUnit complete assertions and assumptions API for the Brave. I'm just using a JUnit complete test API for the Brave, just because it wouldn't fit on the line. But we're going through the assertions class. It has a plethora of methods and overloads. Then we're going to finish with the assumptions class, which has just a few, but fairly interesting and important ones. Alright, next page of assert not equals methods. And if you want, feel free to look for the PDF on the course's website. You can download the PDF and you can scour or peruse this PDF at your leisure. If you want to jot some overloads down and train your tactile memory better. Alright, next page, we're still on assert not equals, and but we're probably going through the second part of the assert not equals slides at this point. So alright, next page of assert not equals methods. You see here, I got a duplicate here. So that's an error on my part, just duplicated the methods, but it's not, or perhaps this should be not a wrapper, this should be a primitive. I think that's what happened here. Alright, next page of more assert not equal methods. Alright, next page still on the assert not equals. Another page of assert not equals. Please don't get bored. This is really, knowledge of the API is as important as knowledge of the technology. That's what's a good functional measure of your productivity. So you must know the API as well as you know a technology and its capabilities. Knowing the API gives credence to the phrase hit the ground running. That's what you want. More assert not equals, albeit we're nearing the end of the slides for that particular method. Alright, and we're done with the assert equals and assert not equals. Just by the sheer volume of overloads, you can tell that these are the most popular methods. We're going on to the next static methods of the assertions class called assert true. It has also quite a few overloads, and you can take a look at this overload. It also features a new class called a Boolean supplier, which just supplies a true or false value. Right, let's take 30 seconds per slide as before. Alright, so next is the assert false method, which is the exact mirror image of the assert true method. Let's take 30 seconds. Alright, next is the overload for the assert array equals methods. Let's take 30 seconds. You can see that we got all primitive types of arrays, etc. And I think we have object arrays as well. Next slide for assert array equals. Alright, some more assert array equals overloads. This is as comprehensive as, not to the same amount, but as conceptually comprehensive as assert equals, assert not equals. Alright, another slide of assert array equals. Some more assert array equals. You can see it has object arrays as well. Alright, so the next assertions class method is assert null. And let's take 15 seconds for this slide. Alright, it's mirror image, it's complement assert not null method. Let's take 15 seconds for this slide as well. Alright, assert throws methods. And let's take 15 seconds for this slide. Assert does not throw methods. Let's take 30 seconds for this slide as there are more overloaded methods. You can also see that we got two new, two classes that we haven't seen before, but that we delved into at some other lectures: executable functional interface, and one we haven't seen before completely, throw-in supplier. It's basically a functional interface that supplies, potentially supplies an exception. Alright, assert same method overloads. Let's take 15 seconds for this one. Assert not same, which is the complement of the previous method. Let's take 15 seconds for this one. Alright, assert lines match. Let's take 15 seconds for this one. Assert iterable equals methods. Let's take 15 seconds for this one. Remember, iterable is an interface, is a marker interface that you must have in order to use an object in the for each construct in Java, which is relatively new. Alright, assert all methods. Let's take 30 seconds for this one. Assert timeout methods. Let's take 30 seconds for this one. You can see some throw-in supplier here being used as well. Alright, assert timeout preemptively methods. Let's take 30 seconds for this one. Alright, and the fail methods. There are a few, so let's take 30 seconds for this slide. Alright, and we are done with the assertions class. Let's go on to the assumptions class. The first method and its overloads is assume true. And let's take 30 seconds for this method and for its overloads. Next is the complement of assume true, it's assume false, and the overloads for the assumptions class. And we see here interesting functional interface called excuse me, Boolean supplier, etc. Alright, next is the assuming that methods of the assumptions class. Let's take 15 seconds. Alright, this concludes the complete API from the assertions and assumptions classes. The complete JUnit 5.6.2 API as exposed by the framework can be found here. Well, it is truly for the brave because it's vastly more than assertions and assumptions classes. You can look up the PDF file for this appendix, and you can click on this link, JUnit 5.6.2 API reference official. You might go to the latest version. This is still okay. So if you know well the API from the above two classes, you will be able to write your unit tests with these like it was your second nature. So expose a API fanatic in you. I know how much you and everybody else loves it, but this is something you have to do. However, if you learned well from all the 7 lectures, quizzes, and labs, you are by now a JUnit master in control of most of the JUnit API. And I congratulate you for this accomplishment. This is one framework most directly related to the quality of what you do day to day, so great job. For example, if you build furniture, you don't want your furniture to be correct 95% of the time, you want it to be correct 100% of the time. Same with testing for software programs. You want it to be correct, well, ideally 100% of the time. And especially junior developers may not like JUnit all that much, but this is just like if you want to be a good craftsman or a good professional, you must be a good software engineer, and you cannot be a good software engineer if you don't know JUnit for Java, if you were in Java, for example. So that is just something you must teach yourself to do. You must teach yourself to love to do writing unit tests, and then you'll be on your way to turning out good quality software. So this concludes this appendix, and thank you for your time.